Hi, my name is Rachael Tatman. I'm a senior developer advocate at Rasa. Rasa is a company that makes a open source framework for building chatbots, conversational AI, and we also have a free piece of software called Rasa X that helps you to maintain an assistant once it's been put in production and annotate data, evaluate how well it's working, and then improve it over time. And today I want to talk to you about something that I would say is probably not the hottest topic in NLP right now, but that is rules. And a quick overview of the history of NLP as a discipline, NLP here being natural language processing, which I'm sure may be reviewed to many of you, but perhaps new to others. So when the field first started in the 50s to 80s, roughly, there was a lot of focus on specifically rule-based systems, expert systems, things where what the system did was determined by a set of guidelines that had been written by somebody who knew a lot about whatever the topic was. So an example of a rule-based system would be Eliza, which was a chatbot that for every utterance that was passed to the chatbot, would transform that utterance into a question using a set of hand-built heuristics, and then say that to the user, and then continuing that way. So it was sort of like a therapy conversation sort of thing. And then starting in roughly the 90s, there was a big shift away from rules, or sort of like always the same, towards more statistical methods. So methods that were probabilistic, and in particular, this is when corpus-based methods became really popular. So things like counting all the words in the corpus and using that to assign probabilities given an input string to what words would come next. And those methods were statistical, but they weren't deep learning. And it was starting in roughly the 2010s that deep learning became, or neural methods became really popular. So deep learning models are a family of machine learning models. And the particular flavor that was particularly hot when I was in grad school was a bidirectional LSTM with attention, which is a particular type of recurrent neural network. And recurrent neural networks look at a sequence and then they sort of slide over every time step, and each time step look at the previous time steps they have access to when making the decision it is that they're being trained to make. And in 2017, this was when the paper Attention is All You Need came out that proposed the transformer architecture. So RNNs are one family of neural network, another family of neural network are transformers, and they will look at an entire sequence at once and assign, you can think of them almost as weights, attention to each of the items in the sequence, again, depending on what the particular thing is that they're being asked to do. And I would say currently the hottest topic in NLP are large transformer-based language models. So these are not statistical models, but they'll, for example, GPT-3 will, given an input sequence, generate output words, output language based on that input, and that's a transformer system. BERT, another transformer language model that has sort of has been trained to generate language to, in BERT's case, fill in a gap, and in GPT-3's case, continue an existing string. So that's the current state of the art. People are really into transformers, these neural networks. But I would argue that the people who were working on rule-based systems were really onto something, and there are situations that are happening right now, especially in industry, where neural network methods are not going to get you everything that you need. So a quick breakdown of some of the benefits and drawbacks. Rule-based, starting with neural methods. So neural methods have the ability of being flexible. They're probabilistic. They're fairly good at seeing, at handling unseen data and sort of guessing what should happen given the things that it's seen previously. But that comes with some drawbacks. So a big one is that they are unpredictable. So for example, I mentioned that GPT-3 is really good at generating text, but you can't tell before it does it what text it's going to generate. So I don't think it's necessarily a good idea to serve that raw text to users. And they also require a lot of training data. And this is just leaving aside the question of how much time and energy it takes to train the models, which is quite a bit. And time there being time on a machine, not just like clock time. On the other hand, rule-based methods have some big benefits. So the biggest one is they're reliable. If you're using, say, a template system to generate an utterance, so if you've ever gotten an email that's like, thank you for your order of blah, blah, blah from blah, 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 where those two blanks are filled in with the things that are relevant to your particular order, that's a template-based system. Every time that email is sent out, it's going to say the same text around the things that are relevant to that particular user. They're also really easy to interpret. It's really easy to figure out why, well, depending on the number of rules you have, it's pretty straightforward, and you can figure out why a specific output was given for a specific input because you can follow the chain of rules. They also really don't require any training data to be shown to the model because someone builds them by hands. So they're very predictable, they're reliable, they're always going to do the same thing. The downside of rules is that they're very narrowly defined, and if you have many different rules, if you're trying to do everything with rules, you'll often, particularly for chatbots, end up with an enormous data structure that covers just a huge variety of different things, and is very difficult to maintain, complex to sort of hold in your head, and can be difficult to work with, basically. And also they don't adapt to unseen situations. So if you're working with rules and you have a situation you don't have a rule for, your system just can't handle it, right? So let's step aside from the specific techniques and talk about what it is you need to do to make chatbots work. In the current process of making chatbots for most commercial applications, a lot of research applications, these will be done sort of completely sequence to sequence with transformers, but for people who are working in industry, it is more common to have a part of the chatbot that does NLU, natural language understanding, takes the text and converts it into some sort of number that you can use. And then dialogue management, which looks at the numbers for the things that the person has said and other relevant information, and decides what to do next. And then that little response generator, in general, especially if you're starting, I recommend just writing your responses that you want your assistant to say. So how do we do this at Rasa? We actually do use transformers. We do use neural network methods because of the benefits that they have, that they are flexible, that they can handle things that they haven't seen before. So one of the places that we use transformers is in an NLU component that we've developed called the diet classifier. What it does is it takes in text and it identifies what the person was trying to do when they sent that text to the conversational assistant, and also any entities in that text. So things that you might want to store, pieces of information you might want to store and use later in a conversation. And if you're interested in precisely how we use the transformer, here is the full model specification, and as you can see, the transformer is right. Oh, you can't see my mouse. The transformer is sort of the big bar in gray. For dialogue management, deciding what to say next, we also use neural network policies. So we have a couple that we built and recommend. So one is a Keras policy, which uses LSTM, which is a recurrent neural network, sort of the ones from the neural network moment before the current moment, which is more transformer based, that predicts the next action. And we also have a policy that uses transformers, this TED policy. So both of these provide suggestions about what to say next. And what they'll do is they'll look over all of the things that the assistant can say. They will consider all of the training data that they've been given. And considering all the training data that they've been given during training, we'll pick the thing that the assistant should say next to the user or do next. It might be an action that the assistant does, like executing some code. And these work really well because they are flexible and because people don't always say the same things in the same order in conversations. However, we think that very rarely should you only use these policies, and generally you want to also use some rule-based policies. So rules have a lot of places in conversational AI. So just as an example, if you have an assistant that's like a virtual bartender and you sort of recommend mixed drinks based on a fun questionnaire, you absolutely do not want to show that to minors if you're a company that's trying to sell alcohol. So you need to have a rule where you ask somebody's age, and if they're not 21 in the United States, you do not show them the assistant, and that happens absolutely every time. Because if that's a marketing tool, marketing alcohol to minors is a crime. Or if you have somebody who is, for example, deleting their bank account or deleting their account in an online game, you want to make sure that they verify that they do in fact intend to do that, and that they're perhaps, you know, log in one more time for an additional layer of security, and you want to make sure that those steps are always followed every single time somebody tries to delete their account, to help prevent bad actors from deleting accounts or transferring accounts or something. So in situations like that, where it has to be done correctly, a rule policy is really, really helpful. And we used to have actually a number of different policies that we added to help with particular use cases that were sort of, you know, not all together under this one rule policy that says, hey, these are rules, these are always going to happen. And we just recently in our latest major release pulled everything together and is like, hey, these are all trying to do the same thing, right? So another example of where you might want to use a rule is if you're trying to collect several pieces of information to fulfill an order. So perhaps you might need the product name, the quantity, credit card information, address information to place the order, going through and making sure that you get all of those pieces of information every time. Otherwise, trying to place the order isn't going to work. Another great place to use a rule. So we have a number of really important use cases that people need to be able to do to have a conversational AI that will actually work in production that require rules. So I would say that, you know, the rumors of rules death has been greatly exaggerated. I know that they're not sort of the hot thing in research right now, but in practical applications, when people are building systems that have to work and you have to guarantee, for example, that you're not selling alcohol to minors, rules are really, really important to build systems that, you know, solve actual problems. So both rules and neural methods have a place in conversational AI in particular, and I would argue in NLP more broadly. Pure neural methods, very flexible, which is great, not super predictable, can be less great. And also they require a lot of training data, and training data isn't always available. So like I mentioned with the rule, you don't really need training data, right? You just say what's going to happen and it happens. And if you don't have training data available, sometimes a rule can get you, you know, up and off the ground much more quickly. And rule-based systems, I wouldn't say you should use only rules. They tend to be too exact to cover a wide variety of situations. In the context of conversations, a single conversation, even trying to do the same task, may take place in a number of different ways. People may want to do things in different orders. So just rules and trying to capture that with only rules is a little bit, I would say, needlessly difficult. And that's where the neural methods really shine. So rule-based systems, rule systems that are partially neural, partially rule-based, I don't think they're necessarily going to be the big topic at the next ACL conference, but I think they're really important and really necessary for people who are working, you know, in the field, making things and applying the research to build products that we all use every day. All right. Thanks so much. I'm looking forward to some lively discussion, perhaps, and I'll open it up for questions.